All right, let's get started. Looks like I'm on air. Levels look pretty good. Pop my face in the corner. Let's go ahead and do it. All right, so we're going to do Advent of Code, day 2. And this time I came across this blog post by Point Free. And it reminded me that they have a Swift parsing library. And I've never used it before, but it reminds me quite a bit of the NOM parsing library from Rust that I used in last year's Advent of Code series. And I really enjoyed the way that you can sort of create a modular parser. And so I will almost certainly do this depending on the challenge. I haven't read the challenge yet. So, all right, day 2, red-nosed reports. Fortunately, the first location the historians want to search isn't a long walk from the chief historian's office. While the red-nosed reindeer nuclear fusion fission plant appears to contain no sign of the chief historian, the engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. They're quick to add that, since you're already here, they'd really appreciate your help analyzing some unusual data from the red-nosed reactor. You turn to check if the historians are waiting for you, but they seem to have already divided into groups that are currently searching every corner of the facility. You offer to help with the unusual data. The unusual data, your puzzle input, consists of many reports, one report per line. Each report is a list of numbers called levels that are separated by spaces. This example contains 6 reports, each containing 5 levels. The engineers are trying to figure out which reports are safe. The red-nosed reactor safety systems can only tolerate levels that are either gradually increasing or gradually decreasing. So a report only counts safe if both of the following are true. Hey Samuel, how are you? Good to see you here. Okay, the levels are all increasing or all decreasing, and any 2 adjacent levels differ by at least 1 and at most 3. In the example above, the reports can be found safe or unsafe by checking these rules. 7, 6, 4, 2, 1. Safe because the levels are all decreasing by 1 or 2. Unsafe. All right, so in this 2 reports are safe. Analyze the unusual data from the engineer. How many reports are safe? Okay. Seems pretty easy, and I'm not going to need the parsing library for this. This one's super simple, but maybe this is a good idea to just use it anyway to start with something simple. So, yeah, we can do that. Let's jump over to Terminal. Go to our Advent of Code 2024 Swift. And I am pushing this up to my GitHub. So we're going to open up the package.swift just to make a quick change in Vim. We're going to add a day 2 executable. And then for targets, we're going to do the exact same thing here and add a day 2 target. I may figure out a better way to do this without having to repeat this every single day, but for now, this is fine. Day 2, test day 2. Okay, and then that means that we now need a day 2 folder, and then also a day 2 folder here. Okay, I think that's good enough for us to open this in Xcode. And of course, our day 2 package doesn't contain any files yet, so we'll fix that. And while I'm at it, I will go grab the Swift parsing URL from GitHub. I'll also touch sources day 2 main.swift just so that we have one. And then here I'm going to add the package with URL like that. And then the version number that they have is 0.13.0. Okay, so then day 2 can depend on that package. Product name parsing. Parsing. From the package, Swift parsing. Okay. And let's check Xcode. Okay, let's look at day 2. We'll do a build. Build failed. Let's see. Target case path macros must be enabled before it can be used. Okay, yeah. That's just a security thing for that. And then let's create a new empty file for our input.txt, so that we avoid that error. And now we have our Swift parsing library ready to go. Okay, so just like last time, I'm going to start with day 2 tests. Let's just copy all of this. And then go over here and new file from clipboard. We'll rename it to day 2 tests. Day 2 tests, and this will be created. Today is the 2nd. We'll import day 2, and then we'll do part 1. Yeah, I really feel like a little bit of boilerplate, a little bit of help on the boilerplate would help tremendously here. Let's go back over here and we'll copy this sample data. We're going to be doing day 2, part 1. Okay, and it can't find that, so let's go into our main file here and we will do enum day 2 and static func part 1 input string returns a string. Okay, build failed. All right, we need to change our target to be 10.15 in our package. So let's do that here. Platforms, and we'll do Mac OS 10.15. Okay. Now we should be able to run this and it should fail. We actually expect the output to be 2. Okay, perfect. So now let's go over to our day 2 test, and we're going to import parsing. We'll also need Foundation for some string manipulation in a bit. And I do not know how to use this library, so let's take a look. See, getting started. We need a struct for the each row that we're going to be creating. So what did they call them in the thing? It was a report, and then each one has levels. So we'll have a report, and then this will be levels, which will be an array of integers, and we can initialize that to an empty array. A naive approach would be able to use split separator. I take offense to that. This is a way to do it. All right, so we're gonna say parse with some input. We can start by describing what it means to parse a single row, first by parsing an integer off the front of the string and then parsing a comma. We can do this by using the parse type, which acts as an entry point into describing a list of parsers you want to run one after the other to consume from an input. Okay, note that this parsing library is quite general. allowing one to parse any kind of input to any kind of output. For this reason, we sometimes need to specify the exact input type that the parser can process. In this case, substrings. Already, this can consume the beginning of the input. Try user.parse. Okay, so the parser is going to be created. Let's say let parser equals a parser for the input is going to be substring.self, and then we're going to do int.parser. Is that what it says? Just int.parser? Input could not be, oh sorry, that's not parser, that's just parse. And then we need any kind of white space. And I'm not sure how to deal with white space here yet. We could just do a single space here because I know it's going to be a single space. Okay, so then if I want to parse next we want to take everything up until the next parser for the user's name and then consume the comma. Okay. Bool.parser. And then that gives us, okay, then we can map that. So then we get a map that has an int because that's just an int in our parser. That's actually really nice. Okay, so that's going to be our level in. And that's going to, we're going to need to collect all of those into each row. Let's see. So this is one. I feel like I need to do this in a different way to have a repeated parser of ints. There's got to be a way to do that. Okay, let's see if we can find some more examples here. Documentation. Parsers. Okay, so we've got to have like an array. One of many. A parser that attempts to run a number of parsers until one succeeds. No, that's not what I want. Type aliases, always any, many. Parsers.many, okay. What does that mean? Attempts to run another parser as many times as specified, accumulating the result to the outputs. This is exactly what we want. So what we want here, instead of parse, is many, but ints parser. Oh, and then that also has a separator. Can I put that inside then? Many element separator. Yeah, so this is going to be int.parser. And then the separator will be a space. Okay, so now this should be levels. It should be an array. Yeah. Okay, so now we can recreate a new report with those levels. And that means we don't need this or that because it's just always going to be created. Okay. So that works. And then back on this getting started guide, to make the data we are parsing more prominent, parse int with this parser Okay, and then to do many, to parse multiple users from the input, we can use the many separated by a new line. Oh, that's nice. Okay, so this is going to be a report parser. And then we can have another one that takes all the input. Input parser equals parse. Input is substring.self. And then I think that's actually going to be, yeah, it is going to be string substring.self. But I don't think I actually need it to do that. So this, I guess this is just going to be reports equals many. And then the element here is report parser. And the separator here is new line. Okay. And for now, let's just say reports.parse input. And I think I'm just going to do this in one line. So we'll do this dot parse dot parse. So how do I want to format this? We'll do it like this, dot parse input. And now we've got port. Now let's return, we'll do print reports. Okay. We're gonna make this throws so that it can be caught somewhere else and we don't have to deal with it in this method. Okay, let's see. Day 2 test is going to fail here because this needs to throw as well. We'll do try await and then let's run it. And the test failed, but did we get our reports? Report levels, yeah, 76421. 12789. Okay, so that was actually a good idea to try the parsing on something smaller. I like that idea. Okay, so I now can hit Control Option Command G to just continue to run that test over and over again because it's the same test every time. So what we need to do now is figure out how to decide. So it's going to be something like let safe reports. Is it safe that they called it? Yeah. Safe reports is going to be reports.filter. And then what we're going to say report, and we can just say report.isSafe. Which means I think we can do is safe like that. And this can return safe reports.count. So then here we'll do is safe bool. And then here we'll say all satisfy. Actually, no, I can't do that. We're going to have to make sure that we're going to have to zip it with itself. So we're going to say zip levels with levels.drop first. So now we're going to get all the pairs, and then we can do all satisfy, and this is going to give us A and B. And we can return A is greater than B. And I think that they are all increasing or all decreasing. So it's going to be, let's see. we're going to need to know, let's say, decreasing. Let's just assume that we have we're going to do that, else return false, just to protect ourselves, because I'm going to just say let is decreasing equals levels 0 is greater than levels 1. Else needs to go here. So that way we don't need to run through the collection twice. We just peek at the first two, and we're going to assume that the rest of them are going to be decreasing. So let's see. Let compare func is equal to is decreasing. Can I do this? I don't think so. Yeah, I'm going to have to say, okay, if we're decreasing, and A is greater than or equal to B, I don't think all increasing or decreasing, they differ by at least 1 and at most 3. I suppose that I would just care if it's positive or negative to get the difference. A minus B. So for the first one, it would be 7 minus 6 is 1. If, let's do B minus A, so that decreasing ends up being negative. And then we will say, times is decreasing. Actually, no, I'm going to do A minus B. So if it's that, we're going to multiply it by -1 to flip the sign. And then we're going to return the diff is greater than or equal to 1 and the diff is less than or equal to 3. I think that'll work. So that needs to be that. Okay. And we're going to return this. Test failed. What did we return here? Output 0. Expected 2. Okay, let's just hit a breakpoint here and see what we get for this first one. A is 7, and B is 6. So the diff here is 7 minus 6. Oh. Parentheses are kind of important in math. Let's run that again. And now we get test failed here, still getting 0. Seven and 6, the diff is -1. No, that shouldn't be. Sorry, this needs to be reversed. All right, one more time. Okay. Diff is 2. Okay, I think that's good. Test succeeded. All right, so let's take a look at the puzzle input. Looks like the number of levels 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Yeah, so there's different lengths, but that's fine. We don't have any that are less than 2. All right, so let's go over here and paste that in our input here. And then in our main function, we did the exact same thing here in our main here, and I want this to be something that we can do more than one. Like, I want a helper function that we can use. So what I'm going to do here is make a target called a, what do I want to do? Binary target, executable target. Where's library? Why does it say system library target? That's kind of interesting. Don't I want like framework here? I'm forgetting the syntax. Swift package manager. Package dependencies. No. It's just a target. Oh, duh, that goes in the product section. My bad. This is where I want library. Name is going to be AOC helper. Yeah. Then we just have target. Name AOC helper. For right now, it will not have a... That will not have a dependency or resources or tests for right now. So then I'm going to change this one to have dependencies on AOC helper. Oh, I love that Xcode has dot to repeat Vim motions. That is one of the huge things that we were missing. And then I think that came with Xcode 16. Okay, so now we've got this AOC helper. I need to create a directory. And then a new empty file. This is going to be I don't know, read input. Public func read input. And then we'll have the input file name is going to be a string, but we know it's going to be the input.txt most of the time. This will throw and return a string. Okay, so the interesting thing now is that we don't have the module name of the caller to read this from that caller's module. I think I'm going to have to pass in the bundle from bundle. That means I need a foundation here. So if we look at day 1, I mean, I'm not really saving lots of time here, but if I'm going to do this 20 times, it would be nice for me to be able to do this. Okay, so we're going to say input file name. We can, no extension here. This can be try, and instead of bundle.module, it'll just be bundle. Oh wait, that's not try. That ends up being, yeah, okay, we'll do that. We could say guard let URL, else fatal error, can't find in bundle. Input file name. Okay. Then this one, we can give it an empty string if it's invalid data, or do another guard. Maybe we'll do that just to give ourselves good error messages. Guard let input is that, else fatal error. Can't read that as UTF-8, and then return input. Okay, so now here, this ends up becoming if I import AOC helper, this becomes read input from bundle, and that can be .module. And then I can do try. Okay, so I'm going to do that and then paste it into part 2. Day 2, part 1. Comment that out for a second. And we need to import AOC helper. This can throw, so we'll try there. Build. An undefined method, AOC helper. Let's take a look at our package. Did I add it to... I did it to the wrong target. That needs to go here. AOC helper. I don't need it there. df space there, and then we'll pass that in here. So this now needs to be target AOC helper. Okay, let's run day 2. I don't know if it matters. You could throw since this function throws instead of fatal error, right? Yeah, it doesn't matter here because I'm always going to be running these in command line, and so the end result is I just want the error printed to the terminal. But yeah, I would, in a real app, I would create errors for that. Let's see, we don't need this. Let's paste in the answer, 314. That's the right answer, part 2. Before I continue, let's make sure and avoid printing out all the reports, because we know that's correct. Okay, the engineers are surprised by the low number of safe reports until they realize I forgot to tell you about the problem dampener. The problem dampener is a reactor-mounted module that lets the reactor safety system tolerate a single bad level in what would otherwise be a safe report. It's like the bad level never happened. Now the same rules apply as before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. Okay. Fun. So I think I'm going to change this is safe to have a tolerance, maybe. All right. Nope, here comes another one. Ah, false alarm. Okay, yeah, let's do func is safe tolerance int equals 0, returns a bool. So the weird thing about this is because I did this in a functional way. If I were to mutate state, let's say I have remaining, let's say tolerance here starts off at tolerance. So I'm just like redeclaring this as immutable copy. And then inside of here, let is safe is this. And then we'll say, if not is safe, we're going to subtract from the tolerance, and we're going to return is safe or tolerance is less than or equal to 0. But the problem here is that I've captured this value type. So we're not actually mutating this. I'm not sure if that's entirely correct. Let's find out. Okay, let's set a breakpoint. Just rerun the same test again. Why is say scheme 2 is not testable? That's weird. I have to switch back to the package every time. Cannot infer key path. Oh yeah, so now this becomes filter $0.isSafe tolerance. Let's say the tolerance here is 2, just so that I have a number bigger than 0 to work with. So at this point, tolerance is 2. It's safe, so we'll continue. That one's also safe, so we'll continue. Safe. Safe. Okay, so this one is not safe, so we do tolerance minus equals 1 and continue. But see, now tolerance is 2 because we're just capturing a value type every time through this loop. So one way to make that work would be to make this a reference type, like a box type, and then mutate inside of here. But that just sort of destroys the functional nature of this. I don't know if I care. I think that this is one of the things to think about. A functional way would be for somehow for us to maintain this tolerance all the way through. Like maybe instead of just returning all satisfy, maybe we reduce this to say that, yeah, I actually like that better. So let's, instead of doing this, we're gonna map these two, A and B, and we're gonna do the same thing here. And we're gonna return is safe. So now we're gonna have an array of Booleans. And then we can say, let's see, count where. Yeah, I think I could do this. Not count where. Count. Yeah, count where $0 gives us the ones that are safe. I want the unsafe ones, and that's less than or equal to our tolerance. Yeah, now we continue to have a functional way, so we're just transforming the levels into their corresponding safe values from one number to the next, and check to see if the tolerance is less than 0. Or sorry, less than or equal to the tolerance. And this one is going to fail because it's just part 1 and we're getting a much bigger number now. So this one's tolerance needs to go back to 0. Also, now that I have all of this parsing stuff, now we can make that a static func parse reports from input, throws, returns an array of report, because we're going to use this here. and then that can just return. Okay, then this is going to be parse reports input. That needs to be a try. And now we have essentially our entire part 2 written for us. The tolerance here is 1. Okay, and then we can go down here and return run part 2. Try. Day 2. Which I didn't actually run my test again to make sure it passed, but that's fine. Okay, we got 370. That's not the right answer. Your answer is too low. Okay, let's see. Safe, unsafe regardless of which level is removed. Oh, I can't do that. Okay. Okay, so you can't just look at the 2 numbers. We have to know if I remove a level, if it's still safe. Okay, so this changes it quite a bit. So I could so the problem is I can't just remove an unsafe one. Once I remove an unsafe one, I have to check again. I think what I would end up needing to do here is for each one here, maybe I would return A and is safe. Let's see what that gives us. Let's just return false for a moment. And we'll call this values. And we're gonna print values. So if we do this and I run that test again, okay, so I've got 7 is safe with the next number, 6 is safe with the next number, 4 is safe with the next number, and 2 is safe with the next number. So what that would mean is that if there's I don't think I can do this in this functional way anymore. At least I can't think of one. Because what I'm missing here is 7 is paired with 6. I'm missing the 1. So if the 1 was, let's say that this one is deemed unsafe. We don't know if it's the 7 or the 6 that's the problem. It's another argument for not having shared code between the two day 1 and day 2 challenges. So I think what I'm going to do here is go back to what I had so I can copy this. And we're going to put that inside of part 1. And that's going to have to pass in the report. Either that or just rename it part 1 is safe. I'll do that. That's a little easier. And where is... There it is. Part 1 is safe. So each time it's unsafe, you got to check again by removing a number. Yeah, and you don't know which number to remove, so I mean, you could brute force it, but that is generally, I mean, it just hurts me to do stuff like that because I know there's a better way. But also, there's going to be challenges here where the whole point is for you to like maybe stumble into a brute force approach and then realize that's untenable for the amount of memory or whatever that or it may just take forever because of the size of the data that you're working with. In this case, I think brute forcing would be fine, but there's got to be a smarter way to do it. Okay, so if I go back up here, func part 2 is safe. Tolerance int bool. I suppose I could make them the exact same shape. Okay, so this just needs to return is safe. In fact, I can go back to all satisfy here and get rid of the tolerance entirely because we don't need it for part 1. Return is safe. Okay, part 2 is safe with tolerance. All right, so let's rethink this. We're going to do the same thing with the is decreasing check. So we know if one number is so if I have 7, 10, 6, 5, how else would you know what number is a problem? This is kind of what I'm thinking, is that if I have 7 and 10, so as soon as I find that number A and number B are not safe, maybe I can skip that and check to see if this one and this one are safe. And if so, then skip 10. And the tolerance is how far I can skip ahead. And so I think I need to do this with a for loop. So if I do for I in levels.count 0 ... less than, we're going to say var tolerance equals tolerance, or let's say skip ahead equals tolerance. Now we're going to check let current equals levels I and let next equals levels I plus 1. Now we want to see is that safe? So we do next minus current, same thing we did here, right? A minus B, let's just grab this. This is going to be current minus next. let's make a quick is safe A and B Boolean, and then is decreasing. So A int, B int is decreasing. Okay, so let is safe equals is safe. A is current, B is next. Let's just unlabel those parts. And that one might as well, because the labels are fine. Or the variables are fine. Okay, that needs to be A and B. Okay, if not is safe, then we're going to check to see if we have a number in the future. Oh, also we can't check. This needs to be -1, otherwise we're going to walk off the end of the array. If I plus 2 is less than levels.count, okay, not, that needs to be ampersand, ampersand. Let's see, can we skip this number? So then this is going to be if we're not safe, and our, let's just use tolerance here. I thought maybe I would use that in a different way, but tolerance greater than or equal to 0, and we're not at the last element in the array, then we will the completion, let next let next equals levels I plus 2, and then is safe, current next is decreasing, great. Cannot call non-function. I'm going to call that safe to avoid the collision there. Okay, so if we're not safe, we have a tolerance greater than 0, and we're not going to walk past the end of the array, then we'll redefine next and check safe again. I think I want to do var to just reuse this. And now we can check if not safe, or this can be guard now. Guard safe, else return false. And if we got past the end, then return true. But this one is going to have to subtract from tolerance. Okay. Part 1 is safe. Part 2 is safe tolerance 1. All right, let's try this. Missing return in function. This needs to return is safe. And am I at a breakpoint? Why am I at a breakpoint? $323. What did I get last time? I got 370 last time. Now I have less. Okay, we need to run the test again for part 2 to make sure that we got this correct. So day 2 tests, let's test. Well, let's start by making sure that this part 1 test works. Actually, I think I know what the problem is with mine. It doesn't check to see if the first number is the problem. It only checks to see if the second number is the problem. We could maybe artificially include a valid number at the beginning. I don't know. That seems wonky. All right, so part 2. Same thing. This time we expect this to be 4. Yeah, the problem is this succeeds, but our other test input doesn't. So what I want to do now is say I've got 10, 1, 2, 3, 4. That is the problem. I think. Oh, wait, no. Yeah, so this one should be 5. But it's 4. So that's the problem. How am I going to fix that one? What if I try... If it's still not safe, can we skip the current number? No, so this would be var current. So we'll say var current equals levels I plus 1. We already have next, and then we'll check that again. So we subtract. Let's just check this out for each one. Sorry, that needs to be current equals, yeah. Okay, so we are, let's look at our current number. I'm looking for a 10, so I'm just going to keep going until I get 10. Let's edit this. All right, so let's look at all the levels. We've got 10, 1, 2, 3, 4. So next is 1, and it's not safe. We can skip this number. So we're going to check skipping the next number. And doing that is false. So if we're still not safe, can we skip the current number? I don't know why I have this here. I don't want that. Let's run this again. Okay, can we skip the current number instead? So current becomes 1, and next is 2, and that becomes safe. What happened? Guard safe. Wait, current and next. I can't do that because of the decreasing crap. The decreasing check can't check for the first one. Yeah, the is decreasing check is just wrong now. I feel like I just need to check is decreasing again here. If we're going to replace the current number, we may need to recheck for is decreasing. Or we need to check for is decreasing because we could be replacing the number that we used to determine the value. So if I is equal to 0, then we're going to check is decreasing becomes levels 1 is greater than levels 2. Do you like recursive stuff where you handle the first case then the others separately? Are you asking me if I like that type of stuff? I do like recursive algorithms, but sometimes they can get a little bit confusing. When you say handle the first case of like, are they all decreasing? And then allow that to have a tolerance of 1 and then do the separate difference check separately. The reason I'm shying away from that is just because you iterate twice over the same collection. Let's check this and see if this works. Okay, so safe is false. We eat the tolerance. We check if we're safe here. We're not safe there. I is 0, so now is decreasing is going to turn to false. And then this safe should be true. Sweet. Okay, I think that's it. Test failed. What did I get? I got 7 this time. That's no good. The correct number was 4. So we're just going to print out levels was determined safe. Levels. right? No, this one was... Yeah, it's kind of hard to print out something that was... Yeah, I'm not going to print out inside the loop because that'll be noisy and hard to interpret. Okay, so we got 7. 1, 2, 3, 4, 5, 6, 7. Okay, so this one is correct. That one is correct. 9, 7, 6, 2. This one's incorrect. 6 to 2. From 6 to 2, let's just set a breakpoint here where A equals 6 and B equals 2. So we can pause right there and see what it's doing. Is decreasing is true. The diff is 4. How is that determined safe? Oh, I think I know. Okay, hang on. So we are on 97621. Our tolerance at this moment is 1. 97. Oh, that's a problem because it has to be continuous. So what this is going to do is just replace the 6. So if I'm doing this, then I also need to see if the one before is safe with the current one. If I is greater than 0, then we need to check check previous continuity. Is safe. Levels I minus 1. With current is decreasing. Wait, no, that's not going to work. Because safe is going to be false here if we didn't recheck it there. Ugh. So I feel like I need to always check. I is greater than 0. Is safe or true. So this allows us to skip the current number by checking the previous one with the next one. Actually, no, this isn't correct either, is it? Levels I plus 2. So in this case, we'd be checking 6 and 2. So 6 is the current number. So we don't reflip that. Current becomes 2. And then we check levels I minus 1, 7 with 2. And if that's not safe, we bail. Yeah, I think that's gonna work. So in this case, we're not safe. We have tolerance. Our next number is 1. Did I already determine it's safe? Because that one is not correct. Seven, 6, 4, 2, 1 is correct. Because why? Oh, because the diffs are fine. Okay. 8, 6, 4, 4, 1. 1, 3, 6, 7, 9 is correct. 10, 1, 2, 3, 4 is correct. Okay. I think that's it. This is a little bit fiddly. Would have liked to come up with a better algorithm for this. Holy moly, this is slow. Oh, it's my breakpoint. It's evaluating this every time through. I still got too low of a number. At least I know which ones were considered safe. I could potentially go through there. But if my number was 370 and it said it was too low, then I'm missing another case. So let's see, should this one be considered safe? 11, 10, 11, 12, 12, 5. So this is increasing. 10, 11, 12. And we can get rid of this one. And that's correct. 67, 67. So we'd have to get rid of one of the 67s. So it becomes 68, 9, 70, 73, 74, 75. That's correct. 4 to 8 is 4. That's too much. So we'd have to drop the 4. And we'd get 8, 9, 11, 12, 15. That's correct. 80 to 86. We'd drop the 80. That seems fine. 95 to 93 is correct. 93 to 90. Skip the 90, 89, 88. I really don't want to check 300 of these. Oh, these are all going to be correct. What I'm missing is others that should be correct that aren't. Let's just poke at the input. A peek at the input and see. So we have 1,000 rows. And I have more unsafe rows than safe rows. Let me just double check again. Unsafe regardless of which level is removed. Unsafe regardless. So yeah, so that makes sense. This one makes sense because 976. You can't remove either of these numbers. The only thing I could think of is maybe I'm missing something at the end. Let's create another test to validate that. So could I do 1, 2, 3, 4, 10 and expect that that output is correct also? Okay, so that's our problem. when we get to the end, so we're going through here. Can we skip this number? Let's see. Let's run. Let's run this test. And let's run this test, and then I will double check. Let's add a levels here. Okay, continue. Okay, so this is the one that we want to check. Current is 1. Next is 2. We're safe. Two and 3, we're safe. 3 and 4, we're safe. And 4 and 10, we are not safe. Oh yeah, that's why. Okay. If we're not safe and tolerance is greater than 0 and I is equal to levels.count, then we're fine. Because it's this check that I just wanted to make sure I wasn't going to walk off the end of the array, which I suppose I could put that inside of here, but that's already kind of big. Let's give that a shot. Still didn't work. Okay, let's run it again with the breakpoint. Oh yeah, I'm in the wrong one. This one. I must have skipped over it. All right. So I just want to go until next equals 10. So just skip right to it. Okay. So now we're looking at 4 and 10. Our tolerance is 1. It's not safe. I equals 3. Oh, this needs to be minus 1. Still, okay. Okay, so 4 and 10. We're not safe. Tolerance is greater than 1. Levels.count. I is equal to levels.count minus 1. Why did it skip that? Oh, I is 3. What? Minus 2. Goodness gracious. off by 1 error is all over the place. All right. Yay. Get rid of the breakpoints. Let's run it. It does seem kind of annoying that I'm having to build all kinds of stuff over and over again. 358. That still seems too low. I'm missing another case. Okay. What other cases might I be missing? Do I need that? No, I+2, that would be wrong. Yeah, I'm stuck at a point where I need a test case that's failing to know what to do here. Like, to know what's wrong. My thought was that maybe I'm not handling a case here. So if we're not at the last one, I would be equal to levels.count -2 to be at the last one. So that means we would be here. So does that mean then, well, if tolerance is greater than 0, then that means we haven't corrected any other numbers. And if we're not safe, we can just return true because we can drop the last number. If we're here, let's say we had 7, 10, 6, 5. So current would be 7, next would be 10. We would be considered safe. So then on the next time around, we'd be on 10 and 6. We would be considered unsafe. So I would be 1 here. It'd be considered unsafe, and we're not on the last one, so we go here. We have tolerance. I+2 would be 3. 0, 1, 2, 3. So we can peek ahead. Oh, we need to be able to peek ahead and replace the other one, because what if we're here? I think that's the case that maybe. No, that one is handled too. Let's do this. We need to check in every position. Let's create another test here. Test part 2. Bad number in every position. Throws. Let output equals try day 2 dot part 2. So here we're gonna do no, we're gonna do 10 1 2 3 3 4 5. Then we're gonna do 1 10 2 3 4 5 2 10 3 10 4 10 and then 5 10. Okay, so we expect all of these to be safe. 1 2 3 4 5 6 cases. Expect output to equal 10. Okay, test failed. That's good. Can't tell which one failed yet. Expected end of input. Oh, okay. Caught error, unexpected input. What did I do wrong here? 1 2 3 4 5 10. Here. Oh, I had a space, I think. Oh, wow. Only 2 of these were correct? Levels was determined safe. 10, 1, 2, 3, 4, 5. How did I get 2 if only 1 was output? Oh, I think because of our early return. So I think we just need to break out of our loop here instead of returning. Oops, not that one, this one. So now it shows the 2 cases that are correct are the 2 that we special cased. Okay, so we know that this one is incorrect now. 1 10 2 3 4 5. Goodness, this is taking a lot longer than I had planned for. Okay, so this case doesn't work. Let's figure out why. We're going to go here. I'm just going to run the breakpoint again. The first time through is fine. Second time through is... Sorry, that needs to go here. Second time through is not okay. So the current one is 1, next is 10. It's not safe. We're not at the end. We are here. So then we can check to see if 2 works. 1 and 2 is true, and we're fine. So then the number is 10. Okay. So if we skip over the number, we need to skip over the number. I need to basically say if we're safe, then I plus equals 1. But I can't do that. I can do this. Skip the number and break. So now we know we're not safe in this block here. And if we check, can we skip the current number? We're already processing it, so there's no need to mutate I there. Let's give this a shot. Okay, we're not safe. We can, now we're safe, so we can skip the number. So now this one's current. Wait. How did I skip all the way out of here? Oh, I can't do that. I need continue. Yeah. We're not safe, so then we skip the number. Sorry, this is the first one. Current is 10. Next is 1. This is the first time through. Second time through is what we need to check. We're not safe. We can jump into here. Here we are safe, so we can skip the number and continue to the next one. So now the current number why didn't that jump me to the next number? I think I do need to do +2 here. Yeah, I need to do +2 because the one I was currently on was 1. Talk about off by 1 errors everywhere. That one's fine. This is the one we want to check. Okay. And it is safe, so we can skip the number, and we know we can skip the number because of the I+2 check there. We continue. Now current should be, what happened? Can I not mutate the I in a for loop? Yeah, you can. So I is 0. We're not safe. So then we set I to to 2. But then when I jump in here, it's 1. All right, so that doesn't work. Let's do var I equals 0, and we'll do a while I less than levels.count minus 1. Yeah, I thought you could do that. What's the point of having a var I if you can't skip? I plus equals 2. So now current is 2. And we're safe. Okay, I think that's fine now. Oh, I've got infinite loops now. All right, so here we're gonna do I plus equals 1. Test failed. Expectation output 6 equals 10. Bad number in every 1, 2, 3, 4, 5, 6. Why did I say 10? It is 6. Okay, that one succeeds. This one succeeds. All right. Cross your fingers. $365. I still think it's too low. Holy moly. All right, I'm gonna have to throw in the towel for now because I ran out of time. I think perhaps I just need to revisit. Well, so I still have more that are not deemed safe. So I'm missing some additional test cases in order to figure this out. So if I was getting too high of a number, then I would be looking at all the things that were deemed safe, and one of them would be incorrect. In this case, maybe I need to include The one thing I'm thinking is that, like, what if something got thrown out here? Something got thrown out here early, and then there was another one that needed to get thrown out later, but that wouldn't work because the tolerance wouldn't allow it. Let's just double check that the reports two adjacent levels differ by at least 1 and at most 3. Let's just triple check our logic here. Is safe is greater than or equal to 1, at least 1 and at most 3. Less than or equal to 3. Okay, that's correct. And then in part 2, we can tolerate a single bad level in what would otherwise be a safe report. Yeah, I think that the approach here is rather complicated. I wonder if it just makes sense to say, check these numbers, and if some are determined unsafe, then check the whole thing again by removing one of the two numbers, and then check the whole thing again by removing one of the other two numbers. I think that's what Samuel was talking about with doing this recursive. It is an inefficient way of solving the problem, but inefficient is better than not solving it. All right. Well, this is a little humbling for day 2 to have bested me, but I will figure this out, and we'll probably come back tomorrow with a solution. And I'll probably peek and see how some other people solve this as well. But thanks for watching, and I will see you again tomorrow.